Okay, class, this is the first of a series of review videos that go along with the final exam. In this one, I'll be talking about sample size problems. Now, first, you have to be able to identify that a problem involves a sample size. And what we're looking for is something like this. A researcher wants to determine what proportion of all community colleges students plan to transfer to a four-year university. How large of a sample must she take in order to be 95% confident her estimate is within 3% of the true percentage? That phrase, how large of a sample, lets you know that we're looking for a sample size. Notice that there's no sample information in the problem. Also, there's a level of confidence and a measure of how close we want to be to the true population value. That lets you know that we're looking for the appropriate sample size. If you read through problem 2 real quickly, and go ahead and pause it if you need to, look for the things that tell you it's a sample size problem. Okay, we have how large of a sample is needed, got a level of confidence, and within a certain amount. So everything there again says it's a sample size problem. Once you have that under control, you need to know whether you're talking about a mean or a proportion. In the first problem, it says that the researcher wants to determine the proportion of all community college students who plan to transfer to a four-year university. Now, if you were to gather this data, you would ask a student, do you plan to transfer? Their answers would be yes or no. Categorical tells us we're dealing with proportions. So the things that we need to know for this problem, getting into StatCrunch, is first the level of confidence, which is 0.95, 95%. We need to know the target proportion, which is an estimate of what that proportion was in maybe a past study. We're not given that here. When that's the case, we leave that as 0.5. It will be defaulted to be 0.5 when you get in there. We need to know the width of the interval. And the width is 2 times the margin of error. The margin of error is the 3%, 0.03. So 2 times 0.03, that will give us 0.06. And we can use StatCrunch to determine the sample size. Now for the second one, is this a proportion or a mean? This researcher is trying to estimate the mean amount that college students spend on rent. So if you were to gather this, besides it saying mean, if you were to gather this data, you would ask students, how much do you spend each month on rent? You're going to get a numerical answer. When we're talking about numerical data, we're dealing with means rather than proportions. Okay, what do we need to know here? Again, we need the level, which this time is 90% or 0.90. We need to have an estimate of the standard deviation. And here we're told that past studies show that that is approximately $200. We need the width, which again is 2 times the margin of error. And that means 2 times 10 because we want it to be within $10. 2 times 10 is 20. And we can use StatCrunch now to find the size of the sample. So let me switch over to that screen. First, for problem 1, the proportion, that's under stat, proportion, 1 sample, width, summary size. The confidence level was 0.95. As I mentioned, the target proportion, unknown, so we leave that as 0.5. The width is what we're going to enter. That was 0.06. And when we press compute, we get the sample size, which was 1,068. Now for the other problem involving the mean, that is under stat, z-stats. This is the only time we use z-stats in this course. 1 sample, width, sample size. The confidence level this time was 0.90 for 90%. The standard deviation we were given as 200, and the width 2 times 10 was 20. Press compute, and we get 1,083. So back to this screen. The sample size for the first problem, 1,068. The second problem, 1,083. Think about first, what tells you it's a sample size problem, looking for how large of a sample we need. Also notice that in each problem, there's no sample size given. Second, you need to be able to tell the difference between proportion and mean. Proportion problem, besides just saying proportion, think about data that are categorical. And the margin of error is usually a percent. For a mean, besides it saying mean, think about data that are numerical, not categorical. And you'll have to have a standard deviation that doesn't show up in a proportion problem.